So as Taylor mentions, watts per foot, which I think a lot of you guys are more familiar with in the heat tracing world. When we talk about heating elements, we talk about watts per square inch. So effectively, that's the heat flux or the heat density on the heating element. And it's selected according to the application. So a very low viscosity fluid with high thermal conductivity, for instance, water, can be heated with relatively high watt densities in the 80 to 90 or even higher, 120, 130 watts per square inch range, because the element is always immersed in the fluid, and always immersed in the liquid, and the liquid will readily remove heat from the element. High viscosity fluids, such as crude oil or bitumen, must be heated at a much lower watt density. And similarly, gases, which are transparent to radiative energy and have a relatively low thermal conductivity, must also be heated with a lower watt density, typically in the 20 to 25 watts per square inch range. Now you'll ask why. Why do we limit the watt density? Why are we concerned about watt density? Why are we concerned about the viscosity of the fluid? High watt densities will generate high sheath temperatures. And these high sheath temperatures can burn processed fluids. For instance, bitumen will burn quite readily if we run higher watt densities because the sheath temperature is just simply too high for the fluid to receive the heat. If you have any impurities or high, heavy hydrocarbons, C6, C8 hydrocarbons, they can coke up on the element, which will have two effects. It reduces the heat transfer, which then results in an increased sheath temperature. So you have this snowball effect that as the element cokes up, or fouls is a term you'll hear from time to time, you'll accelerate the life or the death of the element. And ultimately, the sheath temperature leads to the coil temperature. So that's the resistance coil right at the center of that element. And higher coil temperature means lower sheath life. So you see this graph we're looking at here. Life in hours is a logarithmic scale. So an old, very wise boss of mine once told me that if you increase the coil temperature by 80 Fahrenheit, you cut the element life in half. And you can see that effect on this graph here.